let's discuss what is voltage. To move a charge in a particular direction require some work or energy transfer. Like to move this marker, we need to apply some work. We'll do some work on the marker. Then only the marker moves. Like here also, to move a charge in a particular direction, we require some work or energy transfer. This work is performed by an external electromotive force. This is external electromotive force is typically represented by the battery. Initially, charges will be in rest. Like here, it is a cross section of the wire. Initially, charges will be in rest, but when you connect a battery here, then the battery performs some work on the charge move like this direction. I have told previous video like current moves opposite to the direction the charges. So we take current here. This electromotive force is represented by EMF. This EMF is also known as voltage or potential difference. Potential difference is voltage is denoted by VAB. It is the energy required to move a unit charge from point B to point A. Let's take this is an element. The two terminals. Terminals not points. So terminal A or point A, terminal B or point B. VAB. The voltage of this is VAB. VAB is nothing but it is the energy. It is the energy or work needed to move a charge from point B to point A. By definition, voltage or potential difference is the energy required to move a charge from reference point. Reference point is denoted by minus sign to another point, positive. VAB can be defined as like this. It is energy or work needed to move a charge from point B to another point A. Here, plus or minus sign is used to define reference direction of voltage polarity. Here, they can say point A is at VAB potential higher than point B, or the potential at A with respect to B is VAB, and VAB is equal to minus VBA. Let's take another example. Plus minus it is A is B. There are two terminals A and B, and there is a voltage of 9 volt. This can be defined like this. Point A is at 9 volt higher than the point B, or the potential at point A with respect to point B is 9 volt. In voltage, there are two types. One constant voltage is called DC voltage. Second, sinusoidal time varying voltage is called AC voltage. This DC voltage is produced by the battery. AC voltage is produced by the electric generator. Let's see what is power. Power is defined as rate at which energy flows is called power. Power is given by E is equal to dW by dt. Rate at which energy flows is W by dt. In some textbooks, energy is also given by U. So power becomes P is equal to du by dt. This this can be written as P is equal to dW by dq by dt. We know dW by dq is voltage into dq by dt is current. Then P is equal to VI. SI unit is watts. Power is a time varying quantity. If power has positive sign, then power is absorbed. If power has positive sign, then power is absorbed. If power has negative sign, then power is supplied. How to check whether power is absorbed or released? Let's see how to check whether power is absorbed or released. If current enters positive terminal, then power is taken as positive. Then it will become power is given by voltage into current plus 12 watt. Current leaves from the positive terminal. Then power is taken as negative. 4 into 3 minus 12 volt. Another time I will tell power. If power enters the If current enters the positive terminal, then power is taken as positive, or current enters the positive terminal, then power is taken as positive. If current lose the positive terminal, then power is taken as negative minus Vi. Now let's see energy. Energy is the capacity to do work. Energy is given by power into time taken into time. Power is measured in watts, time seconds, but here energy is measured in watts hours. Watt hours or kilowatt hours. Here is an example. 100 watt light bulb is on for 2 hours. Then energy equals energy is power into time. Power 100 watt time for 2. Always take time in hours. Then it becomes 200 watt hours. Also remember, 1 watt hour is equal to 3600 joules. Now let's learn the application of energy. How electricity bill is calculated. Let's use fan as an example. Power rating of this fan given 75 watts. Used 10 hours per day. Electricity rate 6 per unit. Step 1. Convert power into kilowatt. Convert power to kilowatt. It's given 75 watts. So it will become 75 divided by 1000, 0.075 kilowatts. Step 2. Calculate daily energy use. Energy per day is power into time taken. 0.075 per day we use for 10 hours. So into 10, 0.75 kilowatt hours. Step 3. Calculate monthly energy use. This is per days. So assume in a month there are 30 days. So 0.75 into this is 0.75 kilowatt hour per day and assume 30 days in a month. So it will become 22.5 kilowatt hours. This is for 30 days. Next, step 4. You have to calculate energy cost. Energy cost. Cost is equal to energy rate. The monthly energy is 22.5 to electricity rate is rupees 6 per unit. It will become 135. Here you have to note that 1 kilowatt hour is nothing but 1 unit. So it is 22.5 kilowatt is nothing but 22.5 kilowatt is nothing but 22.5 units. Then per unit is rupees 6 per unit. Then the charge per unit is rupees 6. Then for 22.5 units will be 135. So if we use a 75 watt fan for 10 hours daily, monthly electricity bill for the fan will be rupees 135 at rupees 6 per unit.